Imagine waking up one day and realizing that everything you know is reality might be nothing but an illusion. And no, this isn't science fiction. We're entering an era where machines can manipulate the very fabric of reality. And no one is warning you about the risks. They call them quantum computers. But what's really behind this technology? Whoever controls this power could control the world. In this video, you'll discover why some scientists are excited and others are terrified. The truth about quantum computers might be more disturbing than you think. For most of human history, our greatest technologies were nothing more than our brains, fire, and sharp sticks. We used them to survive, hunt, and build civilizations. But over time, fire turned into power plants, and sharp sticks became nuclear weapons. Still, the most dramatic upgrade wasn't in our tool, it was in our minds. More specifically, in the machines we built to extend our minds. Since the 1960s, our brain-powered machines, computers, have been evolving at lightning speed. They've become exponentially faster, smaller, and smarter year after year. It's like upgrading from a stone hammer to a spaceship in just decades. But now this incredible growth is hitting a wall, a physical wall. Computer parts are getting so tiny that they're approaching the size of individual atoms. And that's where the rules of reality start to get weird. To understand why that's a problem, we need to get back to basics and break down how computers actually work. At their core, computers are built from very simple parts, doing very simple tasks. They represent data, process it, and follow instructions. A computer chip is made of modules, which are made of logic gates, which are made of transistors. And transistors are like tiny light switches. Each one can either let a signal pass or block it, representing a 1 or a 0. These ones and zeros, called bits, are the building blocks of digital information. When you string several bits together, you can represent anything from a number to a pixel on your screen. By combining many transistors, we create logic gates that perform basic decisions. For example, an AND gate will only send a 1 if all of its inputs are also 1. Otherwise, it outputs a 0. Combine enough of these simple gates, and you can build something meaningful, like a circuit that adds 2 numbers. And here's the crazy part. Once you can add, you can multiply. Once you can multiply, you can simulate anything, even the universe. At a basic level, computers are like huge crowds of 7-year-olds solving really simple math problems really fast, over and over again. And they've been getting faster, but maybe not for much longer. Put enough of these little switches together, and you can make a computer that can simulate everything, from the laws of astrophysics to a full game of Zelda. But here's the catch. As these parts get smaller and smaller, we're running into a strange new problem. Quantum physics is starting to mess with our machines. Let's break it down. A transistor is just a super tiny electric switch. It controls the movement of electricity. And electricity is really just electrons hopping from place to place. So when you build a switch, what you're really doing is creating a little gate that either lets electrons through or blocks them. Today, we're making transistors so small that their size is just 14 nanometers. That's about 8 times smaller than the diameter of the HIV virus, and 500 times smaller than a red blood cell. At that scale, things start to get weird. Electrons are no longer following the rules of classic physics. Sometimes, instead of being blocked by a closed gate, they just magically appear on the other side. This bizarre phenomenon is called quantum tunneling, and it makes it nearly impossible to build reliable, tiny computers with traditional parts. In the quantum world, the normal rules just don't apply. It's like trying to build a sandcastle on a beach where the sand disappears and reappears whenever it wants. We've hit a real physical wall, a hard stop in our technological progress. So what do scientists do when the rules stop working? They rewrite them. Instead of fighting the weirdness of quantum physics, they're trying to use it to their advantage by creating something entirely new: quantum computers. In classical computers, the smallest unit of information is a bit, a 1 or a 0. But quantum computers use qubits. A qubit can still be in a state of 0 or 1, but it can also be in something much stranger. A qubit is any two-level quantum system, like the spin of a particle in a magnetic field or a single photon of light. Photons, for example, can have vertical or horizontal polarization, and that can represent a 0 or a 1. But here's where it gets wild. A qubit doesn't have to choose just one. It can exist in both states at the same time. This is called superposition. Imagine flipping a coin that stays spinning in the air forever, never landing until you actually look at it. But the moment you observe the qubit, like passing a photon through a filter, it's forced to decide, vertical or horizontal, 0 or 1. Until then, it exists as a cloud of probabilities, a mix of all its possible states, and you can't predict what it'll be until you measure it. But the moment you measure a qubit, its magical mystery ends. It collapses into just one definite state. This strange behavior called superposition is what makes quantum computing so revolutionary. Let's compare it to regular computers. 4 classical bits can only hold one of 16 possible combinations at a time. 2 to the power of 4 equals 16. So, out of those 16 configurations, you can only work with one at any given moment. But 4 qubits in superposition, they can represent all 16 combinations simultaneously. It's like being able to read every possible outcome of a dice roll at the same time before even throwing it. And it doesn't stop there. With every new qubit added, the power of a quantum computer grows exponentially. Just 20 qubits could hold over 1,000,000 values in parallel. That's not just faster. That's a different kind of thinking altogether. Thinking in every possible outcome at once. Now here comes an even more bizarre twist: entanglement. This is when 2 or more qubits become so deeply linked that whatever happens to one instantly affects the other, no matter how far apart they are, even if one's on the moon. It's as if they share a secret language, reacting to each other faster than the speed of light. Though technically, it doesn't violate physics somehow. That means if you measure one entangled qubit, you instantly know something about its partner without even touching it. It's like 2 friends finishing each other's sentences from opposite sides of the planet. Manipulating qubits is another brain-breaking challenge. A regular computer gate takes simple input and spits out a definite result, easy and predictable. But a quantum gate, it works on inputs that are already in a hazy cloud of possibilities. It twists and rotates probabilities, reshuffling the entire quantum landscape, and sends out another blurry soup of outcomes all without ever choosing a single one until you look. It's not just different math, it's a different reality. So, how does a quantum computer actually do its magic? It starts by setting up some qubits, then applies special quantum gates to entangle them and twist their probabilities like a Rubik's Cube of math. Finally, it measures the result. And that act of measurement collapses all those fuzzy superpositions into a clear sequence of zeros and ones. What this means is wild. A quantum computer doesn't just try out one calculation at a time like a regular computer. It does all the possible calculations at once. Imagine asking 100,000 interns to solve a problem, and instead of giving them a week, you get your answer in seconds, because they all solved it simultaneously in some parallel universe. But there's a twist. You only ever get one result when you measure, and it may or may not be the answer you were hoping for. So quantum computing is kind of like a cosmic slot machine. Powerful, but sometimes unpredictable. Still, with clever design and repeated tries, you can tilt the odds in your favor, making it incredibly efficient, much more than any traditional computer could ever dream of. Now, will quantum computers replace your laptop or smartphone? Probably not, but in certain areas they're light years ahead. Take databases, for example. A normal computer might have to check every single entry to find what you're looking for. That could take forever. But a quantum computer? It only needs to check the square root of that number, turning hours into seconds when dealing with huge amounts of data. That's a total game changer. But the most famous and scariest application of quantum computing: cracking encryption. Right now, your emails, online banking, and even government secrets are protected by encryption that uses a public key, anyone can see it, and a private key, only you can use it. The trick is that figuring out your private key from the public one would take even a supercomputer years of mindless guessing. But a quantum computer? It could blow through that math like a hot knife through butter, turning what was once secure into completely breakable code. But here's where quantum computers truly start to feel like science fiction. With their exponential speed up, what takes normal computers decades could be done in moments. One of the most exciting areas is simulation. Trying to simulate the quantum world of the behavior of particles and atoms is insanely demanding. Even with supercomputers, simulating molecules often ends up slow and frustratingly inaccurate. So, what if we flip the script? Instead of using classical computers to imitate quantum behavior, why not use quantum physics to simulate quantum physics? Sounds obvious, but it could be revolutionary. Quantum simulations might crack some of our most complex biological puzzles. For example, understanding how proteins fold could unlock new cures and redefine medicine as we know it. It's like having a microscope that doesn't just look, but understands how reality builds itself at the tiniest scale. Right now, though, we're still guessing. We don't know whether quantum computers will become specialized tools for scientists or the next technological leap that reshapes the world. We don't even know what the final limits of this technology might be. But there's only one way to find out. Keep pushing forward. So, where does all this leave you? Quantum computers may be the future of technology, but your brain is still the most powerful processor you'll ever own, and it's not even close to its limits. What if you could unlock more of its true potential starting today? That's why we created NeuroCore, a digital system designed to amplify your brain's performance, sharpen your focus, and help you think with greater clarity and speed than ever before. Inspired by the same principles that drive quantum computing, NeuroCore taps into your mental code and optimizes it naturally, intelligently, and efficiently. And right now, for a limited time, you can access NeuroCore with exclusive early access pricing. Don't wait for the future. Upgrade your mind today and be ready for the world that's coming. Click the link below and take control of the most advanced technology on the